Hello and welcome to I Know Dino. Keep up with the latest dinosaur discoveries and science with us. I'm Garrett.
And I'm Sabrina.
And today in our 503rd episode,
we have news about dinosaur bone beds and what we can learn from them.
We also have an interview with Bruce Rubidge, who's an expert in the Karoo Supergroup, which is known for having many fossils.
Yes.
Including dinosaurs. We also have the Dino-It-All Challenge, our second installment of the Dino-It-All Challenge.
And dinosaur of the day, Minotaurasaurus, as well as our fun fact, which is that human voices and bird songs are built from the same genetic blueprint.
Oh, that's interesting.
Mm-hmm.
The larynx and syrinx.
Exactly.
I always think of them as very different structures, so it'll be interesting to hear about how they're similar. But before we get into all of that, as always, we'd like to thank some of our patrons. And this week, we'd like to thank a new patron, and that is my best friend, Lober. Thank you very much for joining.
Yeah, you got a new best friend.
I guess so. I don't know. I think it might be their best friend. I'm not positive about whose best friend Lober is. Could be my best friend, I suppose. And then rounding out our shoutouts, we've got Geraldine, Eodit, TRX Dinosaurs, Leipziger, Jesse P., Witchslayers, Ayrton and Everett, Samo Spinos, and Ellie.
Amazing. Thank you so much for being a Dino-It-All, being part of our community. If you haven't joined already, then we recommend it. You get a lot of different perks like these shoutouts, and also you can request the dinosaur of the day, and of course, connect with fellow Dino-It-Alls. You can join at patreon.com/iknowdino. Jumping into the news, I'm going to start off with a Triceratops bone bed, which tells us more about how Triceratops lived and behaved. Bone beds are always cool because, well, you got the multiple individuals all together, so you can make a lot of inferences.
So it's a multi-taxa or multi-individual bone bed?
Yes. What is that called? A mono bone bed?
Yeah. Monospecific bone bed,
yes.
I guess, if they're all the same species.
It's all Triceratops.
Yeah, some people say bone bed and they mean just an area with a bunch of bones that could be from just one individual. But usually when we're talking about it, we're talking about like multiple individuals in one spot.
Yes. In this case, it's at least 5 Triceratops individuals.
Oh, wow. That's a lot.
Yeah. 1,200 bones and bone fragments.
That's quite a puzzle.
Yes. It's the largest Triceratops bone bed known so far. It's from the Darnell Triceratops bone bed in Wyoming in the U.S. And it was found back in 2013 when the team from Naturalis Biodiversity Center in the Netherlands was looking for a Tyrannosaurus. They found something maybe arguably better.
Yeah. T-Rex is not the state fossil of any state, but I think Triceratops is multiple states, if I remember right.
Mm-hmm. Plus, anytime you find a bone bed, it's pretty cool.
Yes.
So these Triceratops, they died together. They're possibly mired in a swamp. And there's no other species in this bone bed, so just Triceratops.
Monospecific.
Exactly. You've got the 5 individuals. They're different ages. There's no evidence of scavenging, so they're probably buried pretty quickly. And this is from about 67 million years ago. Jimmy DeRouge did their PhD thesis on this and studied high-res photos and did some bone histology, as well as studied isotopes to make a bone bed toolkit and provide an in-depth analysis on Triceratops and how they lived and how social they were. So they looked at the physical and chemical properties of the teeth, for example, and found them to be the same. So this seems to point out some social behavior then of them traveling together.
Okay, because we've talked about before, the chemistry of the bones and teeth can change depending on what you're eating, and also even just traveling on a fairly small scale can change the chemistry a little bit. So if it's all exactly identical, or nearly exactly identical, then they assume that they were all eating the same stuff and therefore maybe living together.
Exactly. There's going to be an exhibit on this bone bed in the fall, this October, at the museum in the Netherlands, which will show all 5 Triceratops. So that's pretty cool.
Yeah.
I didn't have access to the thesis, or at least I couldn't find it, but there have been a number of papers that have been published over the years about this, where Jimmy DeRouge is the lead author with a team. And one of the papers came out in 2022 in paleogeography, paleoclimatology, paleoecology, and that was about the isotopes, the chemical records of Triceratops, where they examine oxygen and carbon isotopes of the bones and teeth. And like we were just saying, it helps figure out your water and food sources that the animal drank and ate. And it also helps figure out the environment and climate and give insights into seasons and whether the animal migrated. So based on this bone bed, it seems that the Triceratops lived between inland forests and coastal floodplains, and they probably drank water from rivers and channels and foraged for food in those types of areas. So it seems that Triceratops was in this wider range of habitats than we thought before, because other studies have found Triceratops to be in more forested or open marsh or floodplain kind of habitats.
Yeah, whenever I think of paleo art of Triceratops, it's usually surrounded by trees.
Yeah.
But I guess not always.
Not always. So there's not much variation between the teeth, which means that they probably didn't migrate because there's just not much variability in those isotopes. And there's probably a whole lot more to learn. I would guess it's summed up in the upcoming exhibit. So if anyone gets to visit in October, let us know.
Cool. Is that what brought this to your attention again, the upcoming exhibit?
Yes.
That's cool. Yeah, a lot of times Triceratops exhibits are a combination of Triceratops into one skeleton. So it'll be interesting to see if they do all 5 of these individually, or if they sort of piece together 1 or 2 or 3 Triceratops skeletons from the bones that they had.
It sounded like it's going to be 5.
That's neat.
Because the whole idea is to show off this bone bed.
Mm-hmm. I think I remember when you were talking about this before and the lack of migrating. And 2 weeks ago, too, I was talking about Lokiceratops, which is from the same sort of area as Triceratops, even though it was a little bit earlier, and how it couldn't move around that much because the theory in that paper was that maybe the other ceratopsians were sort of limiting their range. They were stuck in one place.
Mm-hmm.
But since they only had the one Lokiceratops to go from, they couldn't check the isotopes in the teeth and compare it to a group of them and see if they were all stuck.
Yeah.
I guess they could have looked at the just one and seen if there was a lot of variability, but it's hard to do variability when you have just one individual.
Well, there are studies of mammoth tusks that show where it migrated all over based on the isotopes.
That's true, yeah. I guess if you have a good record of some of the other plants in the area and some of the water that might have been around too, you can get an idea for where it had been.
Mm-hmm.
As another example of why these bone beds are so much more useful than just finding a single individual. And even if you're finding 5 individuals from an existing species, that can be as useful or more useful than finding a new species because it's all new individuals, with new information.
I'd say any find is a good find. Well, I guess there are some times you get fragments where you can't really study them, but...
Yeah, some of those do get left out in the field on occasion. You also mentioned that they looked at the physical properties of the teeth, and I'm assuming that's like wear marks, which also varies when you're eating different stuff. That's something that was figured out way before we were talking about chemistry of teeth and migration. You could look at the micro wear patterns or the macro wear patterns on the teeth to see what they might have been chewing into, if it was tougher plants or softer plants. So if that's also similar in these Triceratops, it gives you an even better idea that maybe they were staying in an area, maybe staying in a group, all eating the same stuff.
Yeah. I'm curious what's in the bone bed toolkit because couldn't find too much information on that.
Oh, that was the thesis paper, was the toolkit?
I don't know. Might have been something separate.
Okay. If anyone knows, let us know.
In other bone bed news, there's a new dinosaur cemetery, as it's been called in the paper, found in Yunnan Province in China. This was published by Hu Xiaobin and others in Geological Review. And it's pretty cool because it's in a new part of the province. So kind of going back in history a little bit, Lufungosaurus was found in 1938, and that kind of kicked off researching and digging for dinosaurs in Yunnan Province in China. And this new bone bed is the first dinosaur skeletal fossil site in the Djadochta Formation. It's from the early Jurassic, and it's in the western part of Yunnan. So it helps show that there's more dinosaurs in this province. And they found this fossil site. It's got 5 layers of dinosaur bones, all from the early Jurassic. It includes vertebrae, parts of the arms and hips. Some of the fossils are well preserved. Some of them they could tell were transported over long distances. But most of them are preserved in situ, which is kind of what you want when you're finding fossils.
Yeah, because that means that you're getting basically the poses they were in, potentially, when they died, or at least when they were finally fossilized.
Mm-hmm. So this bone bed might show some dinosaurs living in groups as well. They probably lived around shallow lakes and rivers and beaches, but they said they need more research to figure out what specific dinosaurs are in this bone bed. It needs to be excavated and prepared, so we're just in the discovery phase for now. Pretty cool.
Yeah. Lufungosaurus is a neat one. It's sort of, I think of it kind of like Plateosaurus-ish in terms of being a little bit more primitive or basal. And it is early Jurassic rather than late Triassic, so it is newer. But it's sort of some of those very first sauropod with like an actual starting to get long neck dinosaur. But it is getting pretty big. It's actually fully quadrupedal, unlike Plateosaurus.
Actually, it walked on 2 legs probably, not 4, because it had longer legs than 4 limbs.
Oh, okay. I think I've definitely seen it depicted on 4 legs, but
yeah,
maybe it the update is that it's on 2 legs.
I think I've seen it both. But yeah, early sauropodomorph looking very sauropody-like. In terms of it's got the long neck and the big body, that sort of thing.
Yeah, but not that long of a neck.
Well,
the beginnings of a long neck. And that's all our news for this episode. It's a little bit early for our first ad break, but I don't want to interrupt the interview, so we're just going to do it now, get it out of the way, and then our conversation with Dr. Bruce Rubidge won't be interrupted. And now on to our interview with Dr. Bruce Rubidge. But of course, as always, we talked more than we aimed to talk about, because when we get going about dinosaurs, we just kind of keep going and going. So we have an extended version of this interview for our patrons. And if you'd like to listen to that, you can go to patreon.com/iknowdino. So we're joined this week by Dr. Bruce Rubidge, who's the Professor Emeritus at the University of Witwatersrand, Johannesburg, and he is an expert on the fossils in the Karoo Supergroup in southern Africa. Thank you very much for joining us.
Thank you, Gareth and Sabrina. It's great fun to be here, and I look forward to sharing knowledge of the Karoo, which is really a wonderful place to look for fossils in the world. It's one of the icons of the world in terms of development of life on land particularly. And then also in South Africa, we're very proud of the fossil record of the Karoo because it's delivered amazing fossils and lots of fossils.
And a wide range of different types of animals, because there are dinosaurs, of course, but there are also mammals and so many other animals.
I think that the important part of the Karoo is that it covers a very long time period.
Yeah.
From 300 million years ago, the end of the Carboniferous period, right until the Middle Jurassic. And so, as you know, at the end of the Carboniferous, call it reptiles, had just appeared on Earth. Up until then, the only animals with backbones were fishes and amphibians. And then they diversified into the sort of diapsid lineage and the synapsid lineage, the one giving rise towards dinosaurs and lizards and crocodiles, and the other one giving rise towards mammals. And the Karoo is noted for all of those two lineages, particularly the ancestry of tortoises and the ancestry of dinosaurs and some of the earliest dinosaurs in the world. And just recently, there have been wonderful new discoveries of dinosaurs in the Karoo, largely because I, working at the University of Witwatersrand, where I headed the Evolutionary Studies Institute, appointed Professor Jonas Schwannier. He was then at the American Museum of Natural History, and I asked him to lead and get going a field-based program to explore the dinosaur wealth of South Africa and see what's there. And he's done exactly that. He's gone out, found fossils, got a whole lot of students involved and international researchers, and they've had great success in finding really exciting stuff, not only in South Africa, but also Karoo-aged rocks through into Zimbabwe as well. So there are all sorts of things that are coming out now. And that's really, I think, the culmination of what we've been trying to achieve in the Karoo. A notable recent lot of research was on dinosaur eggs from the prosauropod Massospondylus, led by Jonas' student, Kimmy Chappell, where she was doing experiments on modern crocodiles and modern chickens to look at embryonic development in crocodiles and chickens and compare them with the Massospondylus embryos to determine the degree of embryonic development. And where previously people had thought that they were on the verge of hatching, Kimi pointed out that they're really at quite an early stage in the embryology. And so these eggs are important because they're some of the oldest dinosaur eggs yet discovered. And the other thing is that they found in several clutches of nests together at different stratigraphic horizons, which showed that these dinosaurs went back there sort of on a seasonal basis to go and roost. And then they found also little footprints of tiny dinosaurs in these nests, the smallest being 1 centimeter, and then the largest being 2 centimeters. And from that, they've deduced that these dinosaurs hatched, and then when they got to sort of twice hatchling size, would leave the nest. So, it's further evidence of mothering in dinosaurs.
Yeah. Yeah, that's cool, because they wouldn't be able to just hang out in the nest for that long without any sort of attention.
Yeah. And then I think the other thing that was exciting was the discovery of a couple of years ago of the dinosaur Laduma hardy, which was described by Jonah. And it is about 4 meters high at the hips. And Jonah described it as the largest land animal at that time. So it was the first of the really large dinosaurs. And that was early Jurassic. So that was a significant discovery. And then I think that in the Elliott Formation, because of the work of Professor Shawneer Jonah and also Professor Emesha Bordi from the University of Cape Town, she and her students have been looking particularly at footprints of dinosaurs, and they've been looking at a temporal sequence of footprints and being able to sort of see from a biostratigraphic point of view how the footprints have changed. And then they've also been getting dates, unfortunately not volcanic ash dates, but detrital zircon dates, which showing or giving quite good dates for that part of the stratigraphic sequence from sort of 218 million years to about 187 million years for that stratigraphic succession. So I think that that's quite exciting. And linked with that is also evidence of the end Triassic extinction and how it affected dinosaur faunas at that stage. So amongst these fossils, these dinosaurs are also fossils of therapsids, the ancestors of mammals, and also some of the oldest mammals fossils known. Things like Megazostrodon and Erythrotherium, which are really tiny little creatures, shoe-sized creatures, which are probably the length of my thumb, and they occurred with these early dinosaurs in the Elliott Formation. And then that was really the culmination of what we expected to find in the Karoo, because we've got very early therapsids, and then gradually, as you go into the younger and younger layers, they become more like mammals. And we find right at the end of the Karoo story, the early mammal story. So I think that's the significance of the Karoo, is it's a largely unbroken record from 300 million years ago to 180 million years ago. And we can look at all of these little changes of how these animals changed from early therapsids through to mammals. And I guess that my interest is on early therapsids. And it started because when I was still a undergraduate student at university, I was doing a geological project in rocks where there were no fossils. And I discovered a fossil Dinocephalian, which is an early type of therapsid. And then I was curious to find out where it fitted in with the rest of the story, because they were not meant to be fossils in those rocks. In fact, those rocks were described as being marine up until then. So I started looking at the rocks and trying to work out the change of environment. And I noticed that where we started finding fossils was on the shoreline of this ancient Karoo Sea. The Karoo started off as in this continent of Pangaea and later Gondwana when the two continents separated. And at that stage, the Karoo was situated over the South Pole, and it was covered by ice. And then gradually, the ice began to melt, climate got warmer, and the area became available for reptiles to colonize land. And so my new fauna that I found then in the Karoo as a result of this discovery. I then went out and looked for more and more fossils, and we found a whole diversity of new forms of very primitive therapsids that hadn't previously been discovered. And we started comparing them with what had been found in Russia. We found ours were slightly more primitive than the Russian forms. And then more recently, there have been forms from China that are slightly more primitive. And so it appears that these animals did have a northern hemisphere origin, but then migrated through to southern Africa or the southern hemisphere via overland migration. And so that's what we've been playing around with. And then as time went on, like any good research project, as you find out more, you need to find out more. And so we started looking for volcanic ashes to get good TIMS dates, and we started getting really reliable dates. The exciting part was we would send the TIMS ashes to MIT. It was the late Professor Sam Bowring, who did our TIMS dating for us. And we knew their stratigraphic horizon, but he didn't know. And so he got them all blinded. And they came out in the right order, which was just fantastic. So we got all these different middle Permian dates and then took them right up to the end of the Permian. And what was exciting about this work is we found 260 million years, all the large species suddenly went extinct. The large dinocephalians, which are animals about 3 to 4 meters long, and with them the pariasaurs also. They all disappeared at that point. And then the smaller animals made it through, and then really a new lot of therapsid forms came on after that. And we then compared that with what was happening in the marine realm, and we found that at Meishan in China, there was an extinction at that time, also in 260 million years at the end of the middle Permian, which corresponded with the marine extinction. So now we've got a good record of that extinction event in the end of the middle Permian from South Africa, and probably the only good record in the world. And also it correlates with the marine extinction from China.
Interesting.
And in South Africa, that probably removed about 80% of species of land-living animals that lived at that stage.
Wow.
And like nobody knows about that one because just a few million years later, right, you get the Permian-Triassic boundary.
That's right. So this extinction is 260 million years ago, the end Guadalupean extinction, the end Middle Permian extinction, and the end Permian extinction is 252 million years, the PT boundary. And that's also extremely well preserved in South Africa. And Professor Roger Smith, also from Wits University, has been working on that for many years. And that is, as you know, at the end of the Permian, it was a major catastrophe. It nearly removed the therapsids. Fortunately, a couple made it through to give rise to us ultimately. And from there, it really knocked out the therapsids at that point, but some made it through. But it paved the way for the origin and radiation of archosaurs and onto dinosaurs after that. So I think the Karoo is noted for the end Middle Permian extinction, the end Permian extinction, and then also the end Triassic extinction, which affected some of the dinosaurs.
Yeah, so that in that, what's tens of millions of years, you've got 3 major extinctions all, and like you said, you've got a complete record practically without a lot of gaps. That's really remarkable. I don't think there's anywhere else in the world that has that sort of record, at least that I know of.
I don't think there is that has all of those 3 things together, those 3 extinction events. And so I think it is significant. And what is nice is that we're getting a lot of international scientists working with us in South Africa to solve these problems and to look into these extinction events and see how they affected biodiversity, who was affected, who disappeared, and who made it through, and what are the characteristics of those that made it through. All of these, particularly the early extinction events, seem to knock out the large forms, and the smaller forms make it through. That's less of a case in Triassic, and Jonah needs to to sort that out. See what's going on over there.
Delegating the hard questions.
So he's got his work cut out for him. Yeah. But I think, he's also got an interdisciplinary team working with him, geologists and geochronologists, and they are lucky in that they have a very good fossil footprint record in the Elliott Formation as well. So they can look at how these animals moved and how they interacted with each other.
Yeah.
When I started in paleontology in the Karoo, which was sort of 40 years ago, probably before you were born,
just
then up until then, relatively few footprints had been discovered. And so we knew very little about how these animals moved, how they walked, and how they interacted. Did they move in herds or did they move singly? And now we've got many more footprint sites. And so for the first time, we've been able to have empirical evidence how, for instance, the Cynodont therapsids lived in herds. Obviously, we suspected it in the past because you find lots of skulls together and skeletons together. But now, from the footprints, which is really the only evidence that the animal actually walked that spot where you're standing, it gives us proper, good empirical evidence for that. But I think part of the fun of collecting in the Karoo is we find lots of fossils. And in the area where I'm working, on the ancient shoreline, they are scarce. We don't find very many there, probably 2-3 a week. But if you go a little bit higher towards the end of the Permian, you can find 60 skulls to 90 skulls a day.
I see why you say that's the 2 or 3 a week are scarce, but I would say in most places, 2 to 3 a week is still a lot.
Yeah, people are excited to get 2 or 3 in like a field season.
Well, I'm heading off next month in 4 weeks' time, again, to the area that doesn't have many. And we just hope that we'll find more this year. We'll see. The exciting part of where we've chosen to go back is, I said to you that I'd found an early Middle Permian therapsids, but higher than that is the better known fauna of Middle Permian therapsids. But there's a sort of a gap between that we haven't been able to find things. And last year, when I went out, we found a whole lot of, in fact, we found 3 new species at that level.
Wow.
So I'm going back to that same site and seeing what we can find out now. So it looks as if we've got a totally new fauna at that level, between what we call now the Eodocynodon zone and what is above that, the Tapinacephalus zone. We've now got a new fauna. So that's going to be the excitement in 2 weeks' time to see what comes out there.
Nice.
But the problem with these rocks is that they're quite hard, and stuff is difficult to prepare, and we can only really get them out with acid, and it takes a long, long time when you're dealing with acid preparation. It's a very slow process.
Do you guys use, I feel like I saw maybe a Massospondylus that made it to a synchrotron or something. Do you ever use those really high-powered X-rays when you just can't get down to the rock and the fossils?
We do. We do use synchrotrons and CT scanning, because at the University of Witwatersrand, I purchased a CT scanner when I was head of the department there. But now with the synchrotron available to us, particularly at Grenoble in France, we're sending quite a lot of specimens across there. The problem is that there's often quite a lot of pyrite in these early fossils, and that tends to obscure detail. And so we've tried neutron scanning as an experiment as well. And we're getting better results, but it's not perfect yet. Mm-hmm. It's amazing what tremendous progress scanning has brought into paleontological research. It suddenly means we can look right inside skulls, see their structure in areas that were completely inaccessible previously. And so where a scanner was sort of, when I initially bought one for Wits University, which is probably 10 years ago now, that was exceptional. Now it's just a part of your everyday toolkit.
Yeah. I'm glad you bought one, because seeing inside like those massive spondylus eggs and things is definitely worth the money.
Yeah, it was fantastic. What was found, when those eggs were first found, then the only way to expose those embryos was mechanical preparation. And the problem is that embryonic bone is so fragile, so brittle, and so thin that you could easily destroy it. Mm-hmm. And when Professor James Kitching, who was the legendary paleontologist in South Africa, discovered more fossils than anybody else probably has ever discovered in the world. And he was later asked by the Americans to accompany them to Antarctica, because in the early 1970s, they were trying to prove that Antarctica was once linked to Southern Africa. And he found the Therapsid Lystrosaurus and Phrynaxodon under Antarctica. And that was the first sort of paleontological evidence, tetrapod evidence, that Antarctica and South Africa were connected once upon a time. But you accept that as general knowledge. In 1970, when I was at university, that wasn't general knowledge. That was groundbreaking stuff.
Yeah. Mm-hmm.
So now the results of these various scanning things are also groundbreaking. And the sort of things that we can find out from scanning now, looking at the paths of nerves and blood vessels, means you can now start looking at nerve innervations of hair and things like that, and determine when hair first originated. And Julien Benoit, also from Wits University, and was my postdoc when he started working on these things, was looking at therapsids and was trying to determine when they became, call it, warm-blooded. At what stage did warm-bloodedness develop in the synapsid lineage? And he finds that looking at the pattern of nerves and blood vessels, particularly the trigeminal nerve, which innervates whiskers, that he thinks that whiskers first appeared about 247 million years ago, which is in the Karoo record also. Wow. The other thing that he started looking at was, the opening in reptiles, there's an opening on the top of the skull, which is an opening through to the pineal gland. It's called the pineal foramen. And that structure has something to do with understanding day length changes and also warm-bloodedness. And Julien found that also at about the 247 million year mark in therapsids, that pineal opening started closing, which is a situation that you have in modern mammals. The pineal foramen is closed and the pineal gland sits down in the brain somewhere. So these are all new discoveries and are exciting new discoveries for the Karoo in South Africa.
Yeah, it sounds like a great place to find all sorts of new information.
Well, and that's part of what we're trying to do now. We try to advertise a little bit the fossil wonders of our country. And that's why we've also now, together with Ancient Odysseys, put together a tour for people wanting to come to the Karoo. And we're arranging the first one for October this year, the 1st to the 15th of October. And we're going to show people some of the superlatives of the Karoo. So they will land in Johannesburg. They'll be taken to the Evolutionary Studies Institute, which is the largest paleontological institute in South Africa, in fact, in Africa. And our strengths in South African paleontology lie largely in the fossils from the Karoo, but also the fossil hominids. As you know, the first sort of ape-man, Australopithecus, was discovered from South Africa, and that skull is in the Evolutionary Studies Institute at the University of Witwatersrand. So people participating in that tour can go and look at the Taung skull, go and look at all these new discoveries of Australopithecus sediba, Homo naledi, Littlefoot. All of those are also housed there. And at the same time, Professor Jonah Schwanier will show them the dinosaur and the new species of dinosaurs that he's discovered and those eggs, the fossilized eggs. And he's also planning to show them the earliest turtle from South Africa. And where I'm working at the base of the Karoo, we've got the earliest tortoise ancestor, turtle ancestor called Minotaurasaurus, which doesn't yet have a carapace, but it has these very broad ribs. Now, a couple of years ago, I moved away from the University of Witwatersrand. I'm still employed by them, but I live in the middle of the Karoo and now in a little place called Graaff-Reinet. And I did that just on reaching retirement age at Wits University because my grandfather collected a collection of fossils in the early 1930s to the 1940s of early Karoo fossils, middle Permian things, middle to late Permian things from around Graaff-Reinet. And because it was one of the pioneering collections of therapsids in the Karoo, and my grandfather who was a farmer, he established a very close working relationship with Dr. Robert Bruce, who was then the doyen of South African paleontology at that stage, and as you will remember, was the discoverer of fossil skulls like Mrs. Play's many therapsids. And he described something like 400 different therapsid species in his life. Now, the interesting thing is that 118 of those species are in my grandfather's collection. Now, I had a student working a couple of years ago, and there's been a lot of lumping of species, particularly Broom's species, because with better preparation techniques and finding more specimens, we can now see the range of variation within a species. So there's been a lot of lumping of Broom species. But I got a student working on those species of Broom to look at how many of the Broom species that he created then still exist today. And it's about 60%. So when you've described 400 species and 200 of your species still exist today, you've done quite well, I think.
Oh, yeah.
Oh, yes.
More than what any modern paleontologist is doing.
Yeah.
Wow.
And we've talked about some of the early paleontologists in the Americas and places where they might have named 100 and like 16 are still valid.
Yeah, exactly. So this tour will then move down to Graaff-Reinet. I will show the people my grandfather's collection and then take them to various sites around in this area, show them therapsids in situ, and then show them how we prepare them and how we take them out. My grandfather's collection is still on the farm, on the family farm, but I'm in the process of setting up a paleontological research institute in Graaff-Reinet, which is going to be a sort of field-based research institute linked to the University of the Witwatersrand. And my grandfather's collection will be on permanent display there for the public. And so I will have these things set up, these fossils all set up by the beginning of October. And these people participating in this tour will be the first visitors to that new center.
Oh, wow.
Awesome.
So that's what we are planning there. But linked also in South Africa are earlier rocks from Ordovician to Devonian age in what we call the Cape Supergroup, which preceded the Karoo Supergroup. And there's been animals of between 350 and 400 million years. A whole lot of new species have recently been discovered. And on this tour, he's going to offer people the opportunity to excavate with him and to work through these layers. And they will find fossils because they are exceptionally rich. But you basically cleave through these rock layers with a chisel, just chop through slowly and expose those fossils. And the exciting part of it, because it's largely unexplored, people participating in this tour of Ancient Odysseys will have the opportunity to maybe discover new species themselves.
Oh,
wow.
That's cool.
Well, that's one of the things of paleontology, isn't it?
Yeah.
You never know what you're going to find on your field trip.
Yes.
So that field trip is going to, that whole excursion goes over 2 weeks, and it also visits game reserves, big 5 game reserves in the Eastern Cape region over here, and then ends up with a trip down to Cape Town. And so people can get information on that by going on looking for time rewind fossil finding.
Nice.
Sounds like an exciting trip.
It does.
I just want to circle back to, you mentioned your grandfather, and you'd mentioned a number of legendary paleontologists, but I know your grandfather and you both have also contributed a whole lot to paleontology. And your grandfather even has the Gorgonapsid rubigia. Did I say that correctly?
Yeah. Rubigia,
Rubigia, yeah, is named after him.
Yeah. It's the biggest Gorgonopsian known, and it's an impressive carnivore. It's obviously an apex carnivore of its time. And there's particularly good specimens of that animal in this collection. And Gorgonopsians were the sort of dominant predators of the end of the Permian. And my grandfather's collection has probably the most spectacular collection of Gorgonopsians of anywhere in the world. It's just fortuitous. It's not necessarily that he went off to look for good Gorgonopsians. But, I grew up with that collection. And so as a little boy, I was always interested in them, but I never realized the significance of them until I really became a professor of paleontology myself. And I realized what my grandfather had achieved in really only a decade of collecting. He'd found more fossils, more new species than any full-time paleontologist nowadays. So I was just really privileged to be in that, and I guess that bug bit quite early in life, and I've chosen to pursue it as a career. And I've been lucky because in the process, right early in my career, with the aid of colleagues, completely new faunas in South Africa.
So you said he was a farmer, and then I assume he stumbled onto these fossils while doing his regular day-to-day work?
Well, that's an interesting story also. My grandfather had 4 children, 3 girls and a boy. My father was the boy. And, when you grow up on a farm in the Karoo, the distances to towns are long. And so you usually have to go and board if you're going to school. So his children were all at boarding school in Graaff-Reinet. And his eldest daughter came home from school. She was 10 years old at that stage. And she said to her father, "Daddy, what are fossils and where do you find them?" And my grandfather said, "I really don't know." But he said, "I think it's something," this in the early 1930s, "I think it's something to do with bone embedded in rock." He said, "Let's go for a picnic and see if we can find a fossil." And they went out and they were just lucky. They found a beautiful Gorgonopsian skull. But you who've got experience in paleontology know that when you find a fossil, it's not all prepared. So Grandpa then, he didn't really know what he was doing, but he used a hammer and chisel and started opening up this thing. And he said that the thing that looked like a horse's head started coming out of the rock. Well, it shows how little he knew about anatomy of these animals, because it certainly doesn't look like a horse's head. But he then got hold of Robert Broom, who was then the sort of doyen paleontologist, particularly of therapsids. He hadn't yet found these early ape-men fossils, Australopithecine fossils in South Africa. And Broom came to look at the specimen and said to Grandpa, "This animal lived here about 250 million years ago." And I think that blew my grandfather's mind. He'd never thought of those sort of time periods. He thought maybe a couple of thousand years or something like this. And so then Broom said to him, "Why don't you present this to the Transvaal Museum?" Where he was working. And Grandpa said, "No, if this animal has been here for 250 million years on this farm, I'm sure it doesn't want to move now." And Broom then said, "Okay, well then go collect more." And so Grandpa then started collecting more fossils. And I mentioned the other name, Kitching, James Kitching. James Kitching also grew up here in the Karoo, in the neighboring little village of New Bethesda. And his father was an overseer of road construction. So my grandfather went to Mr. Croney Kitching, and said to him, "Croney, you looking for this gravel, this blue shale, to fill in the ruts in your road? I'm looking for fossils." And he said to Croney, "If you find fossils, bring them to me and I will pay you for them." And so he struck up a relationship with Croney Kitching, and Croney had 9 children. So he sent them into the mountain over the hill over the weekends, and they would come back with a whole lot of fossils, and then Grandpa and Crony would reach some economic value for those fossils. And that's how my grandfather's collection grew up in the beginning. And the eldest of those children, then James Kitching, then was appointed as the first member of staff of the new Paleontological Institute at the University of Witwatersrand. And his mandate was to go and find fossils from the Karoo, which he did very successfully. He rather legendary figure, because if you add together the number of years that he spent living in a tent in the Karoo, it amounts to 23 years of nights in the Karoo, living in a tent, 23 years of nights. He found more fossils than anybody else has found, and he also went on to find Australopithecines at that famous site at Makapansgat in the northern Transvaal in South Africa. So that really came because of my grandfather introducing the Kitching family into paleontology.
That's amazing. And I know you've also named a number of species yourself, including one you named after your mother, which sounded very sweet.
Yes, that first specimen that I discovered when I was an honors student, it was a beautiful skull. And I was working out for my PhD in the Karoo, and my mom came to visit me. She had terminal cancer, and it was her last visit to me in the field. And on that day, my technician, John Naipuli, found another skull and skeleton of that Tapinocaninus pameli. So I called it after Mom. But John Naipuli is also a legendary fossil finder in this country. He was my technician at the National Museum in Bloemfontein. We worked together for many years in the field, probably about 15 years. He passed away in the first year of COVID, 2020, unfortunately, but he was an old man, well into his 80s by then. In fact, if it wasn't for John, we wouldn't have found that whole new fauna in the Karoo in South Africa. So John Naipuli is a legendary personality as well in South African paleontology, and found many new species, including dinosaurs.
Yeah, that's awesome. It's so cool to hear just how influential that story of your, what would that be? Your great aunt coming home and saying, what's a fossil, and how that, like the butterfly effect of that spreading out into.
Well, and how many people are working together for all these amazing discoveries, because there's so much to learn and so much to find.
Yeah. It is so. And I think the important lesson from this is that if children ask questions, follow up on them, because it could lead to big discoveries. How a simple little question can lead to lots of discoveries, and has led to a new generation of paleontologists in South Africa and students as well. So I think that's the exciting part.
Nice.
So for our listeners, if they wanted to find out more about you and your work, is there a best place for them to go online?
You could see I'm not very good at marketing myself in that sort of way. But if they just search my name on the internet, they will see various podcasts and things that I've done, and YouTube movies and things like that.
Okay. And then one more time, what's the link for the trip in October if anyone's interested?
Okay. I think that they just simply searched Time Rewind Fossil Finding. They'll get it over there.
Awesome.
And that's the beginning of October, 1st to the 15th of October.
Great. Well, thank you so much for joining us. This was a delight, and I loved all the stories, all the information.
Yes.
Can't thank you enough.
Thanks, Garrett. Thanks for your patience in listening to me, and Sabrina. Thank you. I've enjoyed this chat very much.
Thanks again, Bruce, for the great interview. We're excited to hear about how the new research goes in the Karoo, and that first season of people coming to join and share in all of the collections that we were talking about. And now it's time for our Dino-It-All challenge for the week.
Round 2.
Yes. We're recording this before we have the results from round 1, so we're not sure exactly who was the first to answer the questions.
You will get your shout out, though. Don't worry.
We'll do it next week. We'll catch up. Yes, don't worry.
But first, should we reveal the answers from last week?
Sure. So for the first scene where we were talking about the Two Medicine Lake at Glacier National Park in Montana, and there was some mysterious animal swimming in the water that was chasing away swimmers, that dinosaur was Maiasaura.
The good mother lizard.
Yes.
Taking care of its young.
We thought it was kind of fun because it's the Two Medicine Lake, and Maiasaura was from the Two Medicine Formation. Sort of, that was one clue.
Mm-hmm.
But then we put in a lot more clues to make it Maiasaura. It's got its babies behind it. It's got a beak. It was eating plants. So that basically ruled out all of the other dinosaurs except for maybe Troodon and Einiosaurus, but then it was on 2 legs and it was big. So that's how you know it was Maiasaura. And then for the second scene, the one that the hiker saw, that was a Triceratops. Of the 4 answers, 3 of them were ceratopsians, but Protoceratops and Psittacosaurus were too small to be this large animal that we described.
And Rufus is the dodo bird.
Yes. So it wasn't the dodo bird.
No dodo birds have time traveled to this world.
They also don't have horns.
Oh, yes.
So this week we're picking up in Haddonfield, New Jersey. Just after sunrise on a sleepy cul-de-sac in a quiet neighborhood, one resident wakes up and looks out the window while preparing his morning coffee. Rather than the usual empty street, he sees a massive scaly reptile. It doesn't have sharp teeth or sharp claws, but its large size is still intimidating. The dinosaur is making a mess of the neighbor's yard, smelling all the flowers and shrubs, but trampling them in the process. Not sure whether to call animal control, 911, or just get away from the window, he pulls out his phone and starts taking a video. Suddenly, the dinosaur rises onto 2 legs. It carefully surveys its surroundings. It seems very agitated, like it considers something nearby to be a threat. A neighbor opens her door, takes 1 step outside, makes eye contact with the dinosaur, and then rushes back inside, slamming the door behind her. She watches the dinosaur anxiously from the window, wondering what it will do next. The slamming door and sight of the human briefly draws the focus of the dinosaur, but it quickly goes back to surveying the surroundings for something else. The dinosaur rises higher on its 2 feet, concentrating intently towards the main road. It grows increasingly more agitated for the next minute, backing up across several yards and knocking over mailboxes, fences, and garden gnomes in the process. Eventually, it bumps into a large van parked in a driveway, denting the side with its tail. The dinosaur stops and drops to all 4s as if preparing for a fight. A garbage truck rounds the corner to enter the cul-de-sac. The dinosaur must have been able to hear it long before the people inside their houses. As soon as the garbage truck enters the street, the dinosaur rises back up on its hind feet and lets out a long, low boom like an emu. The garbage truck driver slams on the brakes, then slowly reverses off the street. The ruckus draws the attention of more neighbors who are now all watching from their windows. A minute or 2 after the garbage truck is clear from view, the dinosaur seems to relax, and it lowers its head back down into some garden plants. Then the shady green area at the end of the cul-de-sac catches its eye. There are lots of trees, brush, and vines on the trees, all surrounding a small clearing with a couple of benches and signs. The dinosaur rushes to the greenery. It looks happy for a moment as it sniffs around, but when it bends down and grabs a mouthful, the happy look goes away and it opens the jaws on its horse-like head to let the food fall out. It seems confused and agitated. The dinosaur stays on all 4s and climbs down into the ravine behind the benches, leaving the view from the neighbors. So the first question is, which dinosaur was in the New Jersey suburb? There'll be a few answers to choose from at bit.ly/dinochallenge503. And then for our patron scene, after about an hour, another call comes in about the dinosaur. Apparently it wasn't happy with the ravine and seems even more agitated. The caller mentions that it's been sniffing all the plants along the street, but it doesn't seem to like what it smells. Cars become collateral damage as the dinosaur makes its way through the streets. It has several cuts from the scrapes, but that doesn't slow it down. At least it's still very early, so not too many people are out and about. But school buses will be out soon to pick up children, and the morning rush hour will be starting. Someone needs to calm this dinosaur down to make the neighborhood safe to travel through. Perhaps this dinosaur isn't thinking clearly because it can't find any familiar food and it's getting hangry. So the question is, what foods should someone offer to calm this dinosaur down? And there's a few options, and those will be on patreon.com/iknowdino in a poll format. So if you just click on whichever one you think it is, then you'll get entered a second time to win our Dino-tastic prize package.
And remember, whoever answers the fastest will get a shout out on our show. And then at the end of this challenge, after 8 rounds, we will announce the winner, who will be getting the Dynamite package, which, since we last talked, more cool things have been added to this Dynamite prize package. So we have the Spinosaurus tooth from the Mini Museum.
A large Spinosaurus tooth, not just any Spinosaurus tooth.
Yes.
There's a leaf from the Eocene, a real fossilized leaf, courtesy of Ancient Odysseys.
And adding to our prize package, we have a signed poster from the documentary Why Dinosaurs, signed from a bunch of people who worked on and are in the documentary.
And we're expecting to add more stuff to the prize package as well.
Yes. Again, you can get all the details of this Dino Challenge on our website at iknowdino.com. We also talked a lot about it in last week's episode when we were introducing it.
And if you want the complete rules and restrictions, you can go to bit.ly/dinochallenge24, since it's 2024. And then again, to answer this week's Dino-It-All Challenge and enter to win the grand prize, you can head over to bit.ly/dinochallenge503. And that link's in our show notes as well.
So good luck, Dino-It-Alls. We will get to our dinosaur of the day, Minotaurasaurus, in just a moment. But first, we're going to take a quick break for our sponsors. And now on to our dinosaur of the day, Minotaurasaurus, which was a request from PaleoMike716 via our Patreon and Discord, so thanks. Minotaurasaurus was an Ankylosaur that lived in the Late Cretaceous in what is now Mongolia, found in the Djadochta Formation. It was medium-sized, estimated to be almost 14 feet or over 4 meters long, though it might have grown because the type specimen that this estimate's based on wasn't fully grown.
Yeah, 14 feet or 4 meters isn't that big for an Ankylosaur.
Based on its close relatives, Minotaurasaurus had a barrel-like body and short, stocky arms and legs. It would have walked on all fours with its body low to the ground. So think of Ankylosaurus, but maybe spikier and definitely smaller. It was probably covered in armor or osteoderms, and it probably had a tail club. It had a triangle-shaped skull, a small, broad skull that's lower and wider compared to its relative Tarchia. This skull had this, as the authors who described it put it, quote, bull-like appearance with flaring nostrils. There was also this pyramid-shaped ornamentation on the skull, and horns at the end of it, and it had a beak and leaf-shaped teeth. Minotaurasaurus was described in 2009 by Clifford Miles and Clark Miles, who are brothers. The holotype's a skull, and the type and only species is Minotaurasaurus ramachandrani. The genus name Minotaurasaurus means Minos bull reptile. It comes from the Greek mythological creature the Minotaur, which had the head and tail of a bull and the body of a man.
I forgot that the Minotaur lived on Minos, and that's why it's called the Minotaur.
Interesting, though, that you pronounce it Minotaur and Minos.
Yeah, that's true. That's just how I learned it. So you could, if you don't break it down all the way, it's basically the Minotaur dinosaur.
Yeah. And it refers to the skull looking like a bull skull.
Or like a minotaur.
That too. The species name Ramachandrani is in honor of Villanueva S. Ramachandran, who bought the type specimen, and according to the paper, is a, quote, paleontology patron who made sure that this skull was described and made available to science. So the backstory is that the fossil was bought at the Tucson Gem Mineral and Fossil Showcase in Arizona in the U.S., and he bought the skull in 2003 for $10,000 U.S.
Oh, that's pretty cheap.
Yeah, apparently Clifford Miles and Ramachandra were walking around the displays, and Miles said about the skull, "You buy it, I'll name it after you." So we don't know exactly where the fossils were found, and some paleontologists have criticized Minotaurasaurus being described because the fossil may have been taken illegally from Mongolia.
Oh, yeah, that does seem a little bit likely.
Yes. Ramachandran said that he would return the fossil if it was found to have been taken illegally, but it's a little bit unclear what the backstory is. The holotype is at the Victor Valley Museum in California in the US as of now. As I mentioned, it wasn't a fully grown specimen, it was immature, and that's based on the osteoderms being unfused. That's how they know it wasn't fully mature. They did a CT scan and found nodes on the skull that weren't fused to the surface of the skull, but were extensively remodeled bone. In 2013, there was a poster at SVP, the Society of Vertebrate Paleontology, about a second specimen that was found by the American Museum of Natural History and the Mongolian Academy of Sciences, and that specimen included a skull and part of the neck half ring. So they referred it to Minotaurasaurus based on details in the ring scale, the osteoderm, and the horn on the skull. And what's interesting is there's evidence of insect burrows in these fossils that's in a pattern only seen from the Late Cretaceous Gobi localities. They called it a Medusa-like pattern.
Medusa to go along with the Minotaur.
Oh, good call.
Not that they're that related, but...
No, but they're both these legendary creatures.
Yeah, I'm sure there's some connection we can make between the two.
There is a debate over whether Minotaurasaurus is a synonym to Tarchia.
Oh, really?
Yeah, it is closely related. Tarchia was this Ankylosaur. It lived in the Late Cretaceous in what is now Mongolia.
And it was named quite a bit before Minotaurasaurus, so you phrased it in the way it would go. Minotaurasaurus would be a synonym of Tarchia, not the other way around.
Yes.
So Tarchia would be the name that would be used most of the time.
And Tarchia is known for having a larger brain compared to other similar Ankylosaurs. But the skull of Minotaurasaurus is also similar to the Ankylosaur Saikania, which lived in the Late Cretaceous in what is now Mongolia and China.
Yeah, that Saikania is the one that was found around the same time as Tarchia, and that was the less brainy one. That was the one that got compared to Tarchia and had a smaller brain, presumably.
Yes. It has a cool skull, though. It's broad and it was covered in osteoderms, like the top of the snout, the upper eye socket rim, and then there's horns on the back of the skull and horns on the cheeks. Minotaurasaurus also is similar to the Ankylosaur Shanxia, which lived in the Late Cretaceous in what is now China. So it's got a lot of similarities with its relatives. But it was found to be a valid species, Minotaurasaurus, in several studies that found that it had unique features that weren't due to, say, things happening during the fossilization process.
I guess then the only question is if it was still growing, would those unique features change over time and then become more like one of these other dinosaurs?
Maybe, but like some of the features were that they were more flat or horizontal, which made it unique. And they found, for example, the wide flaring nostrils were real and not a preservation thing.
Yeah, I suppose nostrils aren't a thing we usually associate with like ornamentation changing over time.
That's true.
You never know, though.
So Minotaurasaurus lived in a dry environment, and other dinosaurs that lived around the same time and place include dromaeosaurs like Velociraptor, and then you've got oviraptorids like Oviraptor, ankylosaurs like Pinacosaurus, and ceratopsians like Protoceratops. Time for our fun fact of the day, which I'm doing it again this week. It's that human voices and bird songs are built from the same genetic blueprint. And yes, I pretty much took that headline right from the article published on Texas Geosciences. It was really interesting. It talks about the findings of 3 studies from researchers from the University of Texas at Austin, which includes physiologists and developmental biologists. And paleontologist Julia Clark co-led or co-authored the studies. If that name sounds familiar, she's known for her work on the evolution of birds and the dinosaurs most closely related to birds. And I know we have brought her work up on this show a few times. Yeah, it's an example of deep homology, which describes how different tissues or organs can share a common genetic link. So that vocal organ in mammals, reptiles, and amphibians, that's the larynx. And then, like you were saying earlier, Garrett, in birds is the syrinx. So Clark found a syrinx of a duck-like bird that lived in the Late Cretaceous in what is now Antarctica. This is back in 2013. It's the oldest known syrinx, but it's hard to compare with syrinxes of modern birds because most of the studies of bird syrinxes were from the 1800s, turns out, and they didn't have modern imaging back then like the CT scans that we have of this duck-like bird.
Oh, weird. That's a very strange coincidence that you have almost more detail about this old fossilized thing than you do about modern animals.
So what she did is she and a team, they developed new ways to dissect, preserve, and CT scan syrinxes.
Of new syrinxes, right? Like bird syrinxes?
Yes. And the syrinx is the key for communication in birds, so it's important. They did this hummingbird study, for example, which compared the syrinx of a hummingbird to syrinxes of swifts and nightjars, which are two close relatives. And they found all three of them have similarities. That there's some similarities in the vocal folds, but they all make different calls. And swifts and nightjars don't have as many calls as hummingbirds. And hummingbirds can learn complex songs from each other. It's called vocal learning. So there's this common ancestor of all three birds that had these similar structures, and that may have laid the groundwork for hummingbirds to do their vocal learning. They also did an ostrich syrinx study where they found no big differences between syrinxes in adult male and female ostriches, yet male ostriches tended to make a wider variety of sounds, especially when they're being aggressive toward other males.
So like maybe the females could do it as well, they just don't because they're not being aggressive all the time.
Maybe, yeah. So, yeah, like physically they're able to do it in theory, it seems like, but behavior could make a difference.
Yeah.
Because when the researchers visited an ostrich farm, they recorded 11 types of calls for the males, different peeps and gurgles and boos and booms. This might have also included the juveniles, but the female ostriches only had hissing sounds.
At first I was thinking, oh, the females must be nicer and not making as ferocious of noises, but hisses are particularly friendly sounding.
They're just doing their own thing, different behaviors. And then in the third study, they found that the syrinx and the larynx come from different developmental tissues, but that the vocal folds in them have similar tissue composition and they're developed similarly. So it's the same genes that control the development of vocal organs in mice and chicken embryos. And that means that birds and mammals have a similar cellular structure in their vocal tissue. So there's that link. They analyzed the syrinx development in 14 bird species, including like penguins and budgies. I like that name, budgie. So the common ancestor of modern birds probably had a syrinx with two sound sources, like two independently functioning vocal folds. And we see this in songbirds today. Many of them can make two distinct sounds at the same time. So it could be the same in bird ancestors.
Oh, that's cool. So it's sort of like a phylogenetic bracketing of this syrinx.
Yeah.
The complex syrinx.
Exactly. We still don't know when the syrinx first evolved and also whether non-avian dinosaurs had them, because that hasn't been found yet. But wouldn't that be cool? We figured out that dinosaurs could make these two different sounds.
Yeah, that's how a lot of those dinosaurs can mimic so many cool, complex things that we can't pull off because we can only do the one sound at a time, basically. There's some minor exceptions, but they can really one-up us on that mimicry game.
You mean the birds?
Yes.
Yeah.
And maybe dinosaurs. I think we talked one time about a fossilized syrinx, potentially.
A larynx.
Oh, it was a larynx? Oh, okay.
Yes, I had the same thought. But yeah, not yet. Well, that wraps up this episode of I Know Dino. Thank you for listening. Stay tuned. Next week, we will have more of our Dino It All challenge. Plus, there's a new stegosaur to talk about and updates on dinosaurs getting lumped and split. And that has to do with stegosaurs as well as a theropod. If you want more details on the Dino It All challenge, then head over to iknowdino.com. We've got all kinds of good resources there. Thanks for listening, and until next time.